Good evening, my YouTube viewers. Crystal here. What I wanted to do this evening is I wanted to give you my solution to the analytics VIDHIA food demand forecasting competition question. And basically, what I'm going to do is I'm going to read you the problem statement. The problem statement is your client is a meal delivery company which operates in multiple cities. They have various fulfillment centers in these cities for dispatching meal orders to their customers. The client wants you to help these centers with demand forecasting for upcoming weeks so that these centers will plan the stock of raw materials accordingly. The replenishment of majority of raw materials is done on a weekly basis, and since the raw material is perishable, the procurement planning is of utmost importance. Secondly, staffing of the centers is also one area wherein accurate demand forecasts are really helpful. Given the following information, the task is to predict the demand for the next 10 weeks. For the center meal combinations in the test set. Historical data of demand for a product center combination, product meal features such as category, subcategory, current price, and discount information for fulfillment center, like center area, center information, etc. Now, I spent a lot of time working on this question. I tried really hard to get dummies because that's one of the things that you're supposed to be doing is you're supposed to be like getting the get dummies, and I was able to do the get dummies on an individual column, but I wasn't able to add all the columns together to make a data frame, and I found it to be a bit stressful. I'm going to have to do some more research on get dummies on how to do that. So I'll go ahead and give you my outcome, give you my solution to this problem. The first thing I did was I imported the libraries, and you can see my, there we go, it's moving now. And I didn't import very many libraries, and the reason why is because I'm using a different tactic, and you will see the tactic that I'm using as we go along. The next thing I did was I loaded the data sets, and you see we had quite a few data sets that we had to go over. This was our train file. You see it has ID, week, center ID, mail ID, checkout price, base price, emailer for promotion, homepage featured, and num orders. The test file has everything except num orders. We had fulfillment, which was center ID, city mode, region code, center type, and op area. We had the meal, and the meal was meal ID, category, and cuisine. Example sum. So that's what Analytics VIDHIA wanted to see. They wanted to see the ID and num orders. So what I did was I merged 3 data sets together. I merged fulfillment and meal with the train data set, and you can see that this is the outcome. And so we've got 3 data sets combined into one. And then I did the same thing to the test set data set as well. And the only thing that the test data set doesn't have num orders. Then I checked for null values, and there were no null values. So I did not have to, shall we say, replace any null values with other characters. And so what I wanted to do was I wanted to check to see what information in the data sets there was. And so we can see that there are integers, floats, and objects. The train data test, or the data train and the data test. So now what we did was we processed the data, and we processed the data by using a pivot table. And so what we did was we did a pivot table on ID, center ID, mail ID, and we did it on num orders. So you can see all that here. And then we did a pivot table just on num orders, so you can see everything in the num orders. I did a little chart so you can see the num orders, and then so that just tells you what the num orders were. So then I did a pivot table or a group by on the week and num orders, so you can see how many num orders there were every week. And then I did a chart on that, and you can see it was a really big chart because there were a lot of weeks that had to be put into the chart. And then what I did was I created an extra row called profit. And what I did was I subtracted the base price from the checkout price. And when I subtracted the base price from the checkout price, then it occurred to me that this is not a profitable business. I don't know if it was a real business or just figures that somebody made up from somewhere, but it doesn't look to me like it's very profitable because a lot of the values were negative, which means that the company was making a loss. And so in order to, what I did was I just said that if there are any negative values, just make it 0. So here's your profit. So you had 699 or 700 different values of profit because if anything was a negative number, it was just made 0. And there were a lot of negative numbers. You can see that. We did a violin chart on the profit, and you can see most of it was 0. So this company was not making a profit. I think it was probably making a loss. It was making a loss on a lot of their meals. I don't know how they were staying in business. And then what we did was we checked for the emails to see, and then 0, I'm assuming 0 was no and 1 was yes. So definitely 4 times more orders. People didn't receive an emailer for promotion, so the company didn't appear to be promoting itself very well. And you can see that definitely 4 times fewer emails were sent out than not sent out. So the company could have done a lot better for itself if it had sent emails out. Then it checked the home page to see if people, the home page, and that was about 3 times. So 3 times as many people didn't get the home page as did. So again, the company could have been more profitable. It could have had more exposure if they'd made their home page more accessible to people. And so you can see a chart of that. And then so what we did was we checked our city code, and you see there were a lot of cities. There were 51 cities that they delivered to. We did a little violin chart on that, and you can see like, we just had the city code. We didn't have the actual city, but the violin chart gives you a breakdown of which cities were delivered to. We checked the regions. The region was a little bit easier to use because there were only 8 regions. So we did like a little bar chart on the 8 regions. So you had some regions like region 56 that had a lot more, shall we say, business than other regions such as 23, 35, 71, and 93. Then we did a group by on the center type. So the center type was A, B, and C. And I did a little chart on that so you can see that type A was the largest group type, followed by C and then B. So we had to put this under a label encoder because what the computer wants to see is numbers. And then what we did was we did a group by, so you can see that the group types had been the center types had been label encoded, and now they're numbers. So now we were checking the op area, and you can see that there are 30 different op areas. So what we did, because these op areas were floating numbers, they were integers, they were floating numbers. So I used the label encoder to transform them into numbers, which, I just chose to do that. I chose to make everything an integer. So we checked it here again, and so now everything's an integer, but you've got 30 different numbers. And we've got a violin chart, so you'll see number 15 was the most prominent number for the op area. The next thing we checked was the category, and the category tells you what kind of food it was, and there were 14 different categories. So I put it on a bar chart, and you can see that beverages were the highest category. I did that on a label encoder to make it numeric, and then I did a group by, so you can see now all of the categories are numeric. Wanted to see what kind of cuisine it was, and there were 4 different types of cuisine. We put it on a barcode, and you can see Italian was the most prominent cuisine, followed by Thai, Indian, and continental. We put that on a label encoder to transform it into numbers. And then after we did all of that data processing, what we did was we just wanted to see what the data train looks like. So data train has everything. So we had made an extra column called profit, which I didn't do anything with that. And then so checkout price, base price, and profit were floats, and everything else was an integer. So I created a heat map so you can see how the different variables relate to num orders. So now what I did was I tried to do the get dummies, and I did the get dummies the way that you're supposed to do it, the way the documentation tells you how to do it, but I don't think it turned out correctly, and I was working on this all day yesterday and then all this morning, and it was quite stressful when you're trying to do something. So I can take an individual column and I can do a get dummies on that individual column, but when I tried to attach the column to the training set, I couldn't do it. And as you can see with the code, I've done the get dummies on the code, but it doesn't really look to me like it's came out the way it's supposed to. But what I did was on the train site and the test site, I had to drop several columns because I had to drop a few columns because some of them I didn't feel that they were relevant, and others it improved my accuracy. So on the data train set, I dropped num orders ID, center ID, meal ID, checkout price, base price, profit, and city code. And then on data test, I dropped everything except num orders because data test doesn't have numbers. So what we do is we set up our X and Y value. So Y is train num orders. And X is PD get dummies data train, and X test is PD get dummies data test. So you can see X here, and it doesn't look get dummies to me, but that's what it is. And we've got X test, and that doesn't look get dummies to me either, but that's apparently what it is. So now we split our data set for training and testing. So we used train test split, to use the X and Y variable, and our test size is 10% with a random state of 1. And then what we do is we check the shape of X train, X val, and Y train and Y val. Now we do our model selection, and I spent, pretty much all day long trying to find a model. And finally, whenever I tried linear regression, it just didn't work at all. I got like 17%, and I was shocked. I couldn't believe it. And then it just went from there. And then I found out that they use a root mean square. They use a root mean square as a way of testing the accuracy. And so originally, when I finally got it to work, when I finally decided to just test it, and this was on linear regression, I had a root mean square of like 300 or something, 300 and something. But that wasn't so bad, because I looked in the leaderboard, and then I went to the lowest value, and the lowest value was in the 700s. So even though it was bad, it wasn't as bad as it could have been. And then, so I decided to experiment with models to see if I could find a better model, a model that would give me better accuracy. So I was experimenting with gradient boosting on sklearn website, and it just said that this model, HistGradientBoostRegressor, is suitable for large data sets, and this is a large data set. So I settled on that, and it gave me an accuracy of 72%, which was pretty good considering this morning when I first used linear regression, I got an accuracy of like 17%, and I was shocked. And then I was trying to use another gradient boosting regressor, and the accuracy was only 54%. And so a 72% accuracy was a big improvement. And so I decided that I was just going to leave it there. I don't think I'm going to get a better accuracy with Keras. I could try XGBoost and see if I could get a better accuracy with XGBoost, but I'm pretty happy with this. But in business, you need to have a 90% accuracy. But I was looking, and people, they didn't score more than the 40s or less than the 48, 47, 48. So, I might try XGBoost and see if I can improve my accuracy that way. Then we checked our errors, and it said our mean squared error on the test set was 479698835, and that doesn't look very good. And then YPRED gave you an array of numbers, and I really wasn't that happy with the outcome. Gave you an accuracy of 71.67, which, it wasn't too bad, but you need to have 90% if you're working in business. So we did some more tests, and our square root is 72%, which is close to what I had when I submitted the figures to Analytics VidHaya. So you can see here the actual figures opposed to the predicted figures. And so it didn't give you a fantastic output. So we tested on the X test. So I don't know what the values in the X test were, because they didn't give us that information. So we made a submission, and we created a data frame with the submission, and we uploaded it, and this was the outcome. And then what I did was I downloaded the submission, and I submitted it to Analytics VidHaya, and the score that I got was 74.21 of a root mean squared. And then if you check the leaderboard, the highest leaderboard position was 47, and I was 74, so it was like 25 points lower than the highest score. So I may go back and see if I can try XGBoost. I don't know about trying Keras. I haven't had a lot of success with Keras, so I just decided I wanted to stick with the sklearn modules and try to learn the sklearn modules, because there's a lot to learn. And that concludes my demonstration of my solution to the food demand forecasting competition question of Analytics VidHaya. If you like my presentation, please like, subscribe, and share. If you like the work that I do and you want to make a donation, it would be very much appreciated towards me getting a computer with more power, because the computer I have doesn't have more power. And I've got some other things lined up as well. Like tomorrow I'm going to go open up an account somewhere so I can start doing some other things. And I don't get any monetizations because I don't have any subscribers. So if you like, subscribe, and share, it would be very much appreciated. And thank you so much for watching my video. Let me know what you think, any thoughts you have, any comments. If you have any ideas where I can improve the accuracy, certainly I'd be happy to know them. And I look forward to making the next video for you.